Good morning, fellow programmers. Thanks for joining me. I'm T-Pain, and welcome to Secret Projects. In the description below, you'll find links to jump to specific sections of this tutorial. This is because YouTube is foolishly removing annotations. Can you tell I'm a little upset over this? I'm so angry. I'll be using Visual Studio Community Edition, which you can download from visualstudio.com, though you can review this code in any code or text editor. Today's focus will be on the topic of game creation using an Entity Component System and Windows Presentation Foundation, or ECS and WPF. This was done with C# and XAML, neither of which I've actually created tutorials for, but if you've completed either my Python or C++ Basics and Object-Oriented Programming series, you'll be able to dissect my code just fine. Links in the descriptions for both of these series as well. Alright, Stratego. What is Stratego? Stratego is a collectible card game developed in the 1400s that single-handedly contributed to the World Wars 1, 2, 4, 6, and 7.5. Okay, that's just silly. There was no World War 7.5. So what is Stratego? Stratego is a simple two-player board game in which the goal is simply to capture the enemy flag. You are given a set of movable pieces ranging from values 1 to 10. You are also given bombs that kill any piece that touches them, and your flag, which are not movable. So let's go into more rules of this game. When one piece combats another on the board by occupying the same space, the higher value of the two wins. Each player may only move one piece on their turn, and that piece may only move to an unoccupied space or into the same as an enemy to combat. There are exceptions to these rules, however. A spy has a value of 1, and you only have one spy. If the spy attacks a value 10 piece, aka a marshal, it kills the marshal. But if the marshal attacks the spy is killed. The scout has a value of 2, and has unlimited range, so long as there are no obstacles in the way. Miners have a value of 3, and they can defuse and remove bombs. And that's it. All right, so let's go into a live demo of this game. I'm gonna go ahead and click Start at the top, and here is our game. On the top left, we have our history, which is gonna store all the actions of the game. Right down here is our graveyard for pieces, and here is our board. And at the bottom, below the board, we have a button that says Start Game, which we'll click. That takes us into the next phase of the game, the setup phase. So here we have just a few of the pieces. In Stratego, typically you have many more than 5 pieces. This is just for demoing purposes. Otherwise, we'd have to set up 40 individual pieces to occupy every one of these buttons. So I'm just go ahead and select by clicking one of these items and then click where I'm going to place it. And that places our scout. Then I'm going to go ahead and place our miner, our marshal, our bomb, and our flag. This is not very strategic at all, but whatever. And if you so choose, you can actually swap pieces by selecting one and selecting another, and you can alternate their positions until you've got your board set up perfectly. Okay, so click Setup Complete. And then we've switched players. So at this point, player 1 would turn away from the computer screen and player 2 would set up his board. So I'm gonna go ahead and set this up here, 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 bomb, and flag. Perfect. So now we have set up player 2's board. The way I designed this is that player 1 and player 2 are basically going to take control of the computer based on whose turn it is. So now that setup is complete, we click complete, and now we cue in that player 1 is going to hit this button, and notice we can see all the red pieces and all the blue pieces, but without their values being revealed. So this is player 1's turn, so he clicks ready, and let's say he selects the scout piece, number 2, and then he can select anywhere he wants to position this. So I want to go ahead and suicide this guy in to get some information. So he's going to click on the red piece over there. Notice that I can select it again to deselect it, and I can select another piece and see the range of options because all other buttons are disabled based on what the possible moves are for that piece. And again, select it to deselect it. So we're going to go ahead and move the scout all the way and suicide it in. And now that piece is revealed to both players. So it has a value of 3. This is the miner that we just suicided against. And in our history, an action is added that 03 miner defeated 02 scout. So the red player's piece defeated the blue player's piece. That's why it's red. And then in the graveyard, we see the scout has appeared, and now it's in our dead piece area, or graveyard. Let's go ahead and click Ready Player 2. And Player 2 is just going to go ahead and start moving his miner, because we're just going to try to end this game as quickly as possible. So we're going to go ahead and move 10, and now we quickly begin alternating and moving this game forward, moving the pieces forward and advancing this. So 10 is going to go ahead and attack here, and here we see the marshal has defeated the scout, okay, and the miner is going to continue to move forward, and the miner has defeated the bomb. So now we have a scout in the red's graveyard and a bomb in the blue's graveyard. And 10 is going to keep attacking forward, and it says that the marshals suicided against each other because they both defeated each other, and therefore no pieces are revealed and both are removed from the game. And here they are in the graveyard. Okay, ready to play 2, and now let's go ahead and end the game by attacking the flag. It says, with a little tiny pop-up, player 2 wins. Yay, the game's over. All right, so that was a great demo, T-Pain. So let's talk about how we actually built this. Let's start by walking through WPF, which stands for Windows Presentation Foundation. This is only available on Windows machines, as with Visual Studio. So trying to develop on Windows Presentation Foundation for other platforms or other OSs doesn't make much sense. WPF comes with Visual Studio as one of the projects you can create. In my opinion, it's a bloated and overly complex version of PySide and PyQt. It's just got so much features, and it doesn't do a lot of things that I think are logical. It does it in super convoluted ways. I won't get into it. Either way, that's just my opinion of it. So let's go ahead and start out with the Solution Explorer and look at our project. First thing we have in our project is properties, references, and we also have these other 2 files I hid away called appconfig and app.xaml. Those are the files that come automatically with the creation of a WPF project. So we don't really care about any of those. We're not really going to be adjusting any of those at all. Just leaving them as default is fine. Next, we have a folder called ECS, and this is our entity component system. This is where all of our programming files are, right here. Below that, we have our images folder, and that holds all of the images that we're going to be using for each of these buttons. And they're just like null red, null blue, null gray, the spy, sergeant, major, marshal, etc., all the pieces. Okay, finally we have our XAML file, or XAML file, right here, which is our user interface. Under it, you'll find a C# script right here that connects up our ECS files to our user interface. And here, if we select it, we find a bunch of commented out lines that were actually added in automatically when I created this file. And I didn't need them, so I went ahead and killed them. But we're not going to dive into that code. We're just going to instead focus on this. So that's the folder structure for our project. Pretty simple. Just ECS files, which is most of our game, our XAML file, which is our UI, and then our XAML.cs file, which is the connection between our UI and our main game. So as before, as I described, our user interface is just really simple. It's just the history, and then 2 graveyards for each of the players, all of our buttons, and a button at the bottom for each phase of the game, for each transition of the game. So each of these buttons, there's only one thing that I've really made unique on each of them. And I'm gonna go ahead and open up our properties tab right here. And if I select a button and then go into here, right here at the top, this search bar, and just type tag. This is the unique tag that I've applied to each of these buttons. So each button has a tag for a number of its position. So this one is 64. If I select another one, it'll be 75. Each of these tags is just to identify which button is actually being pressed. And so when any button on the board, including the bottom button, is clicked, then it'll activate a certain function and then just pass in this tag value so that we know which button has been pressed. So they all point to the same function, and then the only difference is what tag is being passed in. That's basically it. I could tell you how I lay this out and how each of these buttons are tied into this stuff, how the graveyard's items are created and whatnot, but that's just really unnecessary and it would take us forever. So instead, let's move on to ECS. What is ECS? It's a code architecture typically used for games, and it stands for Entity Component System. Entities are unique containers that hold components. Imagine an entity as an empty box with a number written on the side. It's just that simple. Components are tiny classes that just store data. You can imagine components as like wheels that we tack onto the box, or paint that we use to color the box. Or maybe components is our collection of fingernails. Wait, no, that's kind of gross. It's just stuff that we add to or into the box. Finally, we have our systems, which are the functions that make our game run and manipulate the components and entities. You can think of these as the action we take on the box we have. If there are wheels on the box, we push it. If the box is yellow, it does not get recycled. If it has our collection of fingernails, we empty it into the trash. Okay, so why did I choose ECS? There are 3 reasons I chose to do this project. 1, ECS is very powerful. 2, I wanted to force myself to learn it. And 3, I also wanted to take a short break from doing tutorials and do something I was very curious about. It's important to chase your curiosities to avoid fatigue or burnout from a job or hobby. I do consider this a great hobby, and I don't want to lose my passion for you guys. I don't! I love my passion. I love you guys. Now, I could start by combing through each of these lines of code, but instead I've prepared something much more fancy for you guys. All right, so now I'm going to comb through this giant image that I've created for you guys. The first part I want to focus on is right here, and this is the game phases. When I implemented this was actually just a finite state machine, which I've taught you guys with the Python tutorial. And here we just have our game start, and that transitions to the game setup phase where people place their pieces, and then it transitions to the game pause state. And then it alternates back and forth with the game pause and game unpause until a win condition has been reached and the game is over. That's pretty much all there is to it. So we just have a finite state machine for each of these phases. And we'll dive into the code for just these here in a little bit, and you'll see exactly how simple everything boils down to. Next, let's look at the simple abstract game state class that each of these phases inherits from. And it just has an entity ID, and then it has an enter, execute, and exit function. So the execute function has an int tag here, and that's the button tag for the button that has been clicked. Now let's look at our entities. And this is where stuff starts to get a little bit more complex, and every one of these systems gets more and more huge, I'll say. Next, we have our entity manager. This guy just keeps track of all the entities that are ever going to be created. It's created as a singleton, so there's only ever one entity manager. And all it has is a simple int to generate the next ID every time an entity is created. So for the functions, we have instance, which is to grab the singleton instance of the entity manager. We also have get, so that we can get an entity based on the ID that's passed in. And then we just have an add. And this is where we pass in an entity, it is assigned an ID and added to the entity dictionary. Here is our abstract entity, or our base class entity. Every single entity will have a unique ID, and will have a components dictionary that just has string and then the component that it's going to be holding. So that way we can say, hey, give me the position, and then we can grab the position component. We have an easy way to grab the ID, and then we have an add and remove components for that entity. Perfect. Next, let's look at the instances. Now, here's where stuff starts to get cool. So here we have our piece entity, and we have a position component, so it's location on the board. We have the player number, which player actually owns this piece. Then we have the value, which is the value of the piece. And then if it has been revealed, if the piece has been combated, like if it were a bomb and some other piece hit it, then it would be revealed to the other player that this is a bomb, or this is a spy, or this is whatever it is. Next, we have movable piece entity. Now, this only applies to pieces that can actually move. Piece entities cannot move. They have a position, but they cannot move. However, the movable piece, like could be spy, scout, values 2 through 10 or 1 through 10, all can move. So they therefore all have a range. This becomes important because this is a component that we can search all the entities for. Up here, we can look through all entities and just grab the ones that have the range component, and then we can figure out which pieces are actually selectable. Super cool. We have the action entity for the history on the top left whenever a battle has resolved, so like 2 pieces run into each other. Finally, we have the board entity, and this is going to hold all of our game state information. We have the player for the current player. We have the starting tag for what the person initially clicks. So if they're moving a piece, they select it, and the starting tag gets stored, or starting position gets stored. And if they click it again, then it will cancel out of that action, and the starting tag gets reset. Then we have the game state, which is going to be holding which game phase we are currently in. Then we have the obstacles, which are just the 8 squares in the middle of the board that no piece can occupy. That's what you saw the little rocks in the middle of the board were. And then we have collision table that says if this piece hits that piece, who wins? So either they'll have a win or loss. So it's just a simple Boolean table or a two-dimensional array of Booleans. Or maybe it was lists. I don't remember which I programmed it as. Then we finally have all piece values. And this is just all the piece values that were going to be used to generate the board. So right now I have a whole bunch of length commented out so that we could just do our demo of 5 pieces. Otherwise you can uncomment those out and it'll be 40. And you have yourself a game. Next, we have our components. Here is our component manager. Again, this is also a singleton. We only ever want one component manager. And it has a dictionary for component entities, so that if we want to get any entity that has a particular component, we can grab all entity IDs, which is this list of ints, all entity IDs based off the name of that component. And so very quickly, we can grab all entities that are movable by just asking for all entities with the range component. And then boom, we're good. And then here's our functions. We have get for get the component IDs, and it'll just return a list of ints for all IDs. We have our singleton function here that's just instance to grab the actual component manager. And then we have add. So if a component is added to an entity, then we pass in the string name for that component and then the ID of the entity that's holding it. Finally, then we have the opposite to remove it. And so now let's look at the abstract component. Every single component will have a single name for what type of component it is, and then we'll have the owner ID, which is right there. Then we're going to have a function to grab the name of the component. Finally, we're going to have the constructor for it. And this is with a hashtag. This hashtag means it's protected, so that any component that inherits from this class needs to pass in this stuff. But the constructor is not open, so no abstract components can be instantiated. It's just to keep it purely abstract or purely virtual. Cool. And now I separated all of these components out into individual namespaces based on their functionality. So position is going to be used not just for movable pieces, but also for the button clicks and other miscellaneous stuff. Also, the player is another component that's going to be used everywhere for like the board's current player as well as which piece owns that player. So if it's going to be used by multiple different types of entities, then I wanted to create them here in the utility. Then we have namespace piece, which just has value of int, revealed Boolean, a range of int, and dead. This dead component is a component that I add on to an entity once it has died. It also removes the range function, it removes the revealed, and just keeps the value. So it just has dead and value. My mouse cursor reversed that. Oops. But yeah, that's basically all the stuff that's going to be needed for the pieces. Then we have the stuff for the actions, and it just has player value and regular value for the winners and losers of each. Okay. Then we have the namespace board. It just has an array of ints for the obstacles. That's for every time we generate the board. And we have all pieces list. Here's that. It just has a list of ints. We have game states, and this has two things. It has the current game state, and then it also has a dictionary for all possible game states right here. And the board entity that we saw up here is actually going to be a singleton as well. So in order to make our lives a little bit easier. Then we have starting tag for when a button is clicked. And then we have our collision table component so that we can very quickly figure out what happens when one piece collides with another. And realistically, this should be an array of arrays, but I was lazy and I just created dictionaries. Then we have namespace display. So namespace display has all of our button information, has a dictionary of the tags connected to the WPF buttons. So this is created in the very beginning of the program when with our XAML.cs file. This is created along with our list boxes dictionary. So we pass in the name of the list box and we can grab that, or our group boxes for changing the names of those. At one point I changed one from graveyard to pieces just so that when the player is setting up, it's just a little clearer to the user. Then finally we have our image brushes stored within a two-dimensional array again, or two-dimensional dictionary, because again, I was super freaking lazy. Yeah. And now we could spend a lot of time going through systems but there is just way too many to go through, and it doesn't really make much sense to comb through each of these. There's too much. There's too much. So let's go ahead and kill that. Instead, let's just go ahead and open our game states and see exactly what's going on within this code. It'll make much more sense here. All right, so let's go up to the top. And again, this is our base game state. So this is C#, and it'll look very, very similar to users of C++, but it has some slight weird nuances, like public is actually attached to each individual line, protected is, etc. And I think you can remove like the second ones. I know in C++ you use like public, and then it's like with a colon here, and then everything gets set that way. But yeah, C# a little bit different. Anyways, there's too many differences to go through right now in this tutorial. But yeah, let's just go through it real quick. And so we have our abstract game class, and it just has enter, execute, and exit. Again, the button tag is being passed into the execute function, so we know which button is being pressed. Then we have our start function. So I tried to make this as simple to read as possible, so we know exactly what's going on. We're in the game start. So this is the beginning of the game. What do? We're going to go ahead and update all board images. Okay, so they've been updated. Then we're going to set all buttons to be locked, which is set to true. And then we set the bottom button, which is 0, button 0, which is the button right here at the very bottom of the screen. That's button 0. And we're going to go ahead and set that button to be unlocked. And then we just set the button message to say start game. That is it. That's the whole enter function right there. So when we start up the game, this is all that takes place. Then we're just sitting here and waiting until a button is pressed. And there's only one button that can be pressed, which is the bottom button. Perfect. So once it's pressed, we go ahead and exit. Here we go ahead. This is where it starts to get a little hairy. We have to convert each of these components and explicitly say what the component is that we're grabbing, because the dictionary has just a bunch of abstract components right here. And so it's like, hey, grab this one based on the string, but it doesn't know what kind of component entity is being returned. So we're going to explicitly state it's a component, it's a board component, and it is the game state component that we're actually interested in. And then we're just going to go ahead and say, hey, set the current game states to game setup, and then call the enter function. There you go. So the board is now in a new phase, or a new game state. So now let's look at the game setup. On the enter function, what do? Systems game setup, so we're actually going to the game setup phase, and we're going to be setting up the graveyard, and we're just going to populate the graveyard with all of the pieces that the person's going to have to place. Okay, so then after that, we're going to go ahead and go display board, and we're just going to update all the images. So we're just going to clear the board, and then we're going to go to game setup, and we're going to go ahead and lock invalid placements. So we're just going to make sure that the player can only place pieces where he's supposed to. Then the display board button lock, then we're going to go ahead and lock the bottom button. Set the game board message to set your board, and then set the group box title from graveyard to your pieces. All right, and that's all we do. Then in the execute function, we're just seeing if that last button has been clicked, then we're just going to go ahead and exit. Otherwise, we're just going to go ahead and set the piece. We're going to set the piece, update the board, and lock invalid placements. Because every time you update the board, I think you need to lock the placements or lock invalid placements. Okay, and then we're going to go ahead and make a check and see if the graveyard is empty. Then we're going to go ahead and unlock that last button and set the message to setup complete. Cool. And so on and so forth. I could keep going through each one of these phases because but each one of these gets longer and longer and longer. But basically, you get the simplicity of this. We know based on the namespaces what's being accessed here. So we're going to the systems, we're going to the gameplay phase, and we're accessing the board. And what are we doing? We're switching players. All right, it's just that simple. And if you ever want to look at the code, you can always peek at the definition and see what I did in that code. And usually it's pretty simple. I try to keep these in 5 to 10 lines of code, so it's super digestible. I didn't always make the public and private functions label them correctly, but whatever, it works. I don't really care. It was a passion project. Anyways, yeah, thank you guys so much for watching. Feel free to check out the rest of this code for yourself. The link is in the description. Comment below with your thoughts on this series. I will be doing secret project episodes once or twice a year, maybe. Special thanks and shout out to our supporters on Patreon. Thank you, Jeremy Watt, JK, and Mike Jonas. You guys are heroes! Thank you so much for your support, and as always, like, subscribe, and keep the dream alive.